we got to test this. That means if this is antiderivative of what's inside the integral sign here, then the derivative of this has to be what's inside the integral sign, or at least the integrand function. Okay, so that means that x e to the x minus e to the x plus c prime should be equal to e to the x times e to the x. So question, is it so? Well, just to refresh, we might need a little refresher on the product rule. I'm not sure we've used it yet. But the derivative of x e to the x is derivative of x times e to the x plus x times the derivative of e to the x. Written here. Derivative of x is 1, so we just get an e to the x from this term. Derivative of e to the x is e to the x, so we get x e to the x from this term. So the derivative of the entire expression is, well, the derivative of x e to the x, as we just saw, is x plus x e to the x. We subtract the derivative of e to the x, which is just e to the x, so we get minus e to the x, and derivative of constant is 0. So what does this give us? That just gives us x e to the x. Big old check mark. It is equal to what it should be, proving that this is an antiderivative, is the general antiderivative of this. Without the c, it's an antiderivative, but with the c, it's the general antiderivative, which I think the question asked for. I would have been happy with this, but I do want to see you add that c to get the general antiderivative.